This is the Chapter 4 packet on regression analysis. We'll be exploring the associations between variables. And just once again, want to remind you that the textbook that's referenced throughout is Essential Statistics, Exploring the World Through Data. So Chapter 4.1, Visualizing Variability with a Scatter Plot. In this chapter, we're going to investigate whether two numerical variables are associated, and if so, how to quantify the strength of the association. In our next section, our next class, we'll consider how to make predictions about one of the variables on the basis of the other. So number 2, we're going to start by taking a look at a data set obtained from Zillow.com. Following data contains information about the price, and it's given in dollars, and the size in square feet of a number of houses for sale in Greenfield, Mass. In February 2016. And so if we take a look, what we'll find is that there are 22 houses in this data set. And each house has two values paired up with it. So we've got the price and the size. Right, so notice that the prices have been listed in ascending order. Do you notice any pattern between the price of a house and the corresponding size of the house? So if we take a closer look for the column for price, notice as we go down, the prices are getting larger or bigger and bigger. So that's the ascending order. If you look at the sizes that go with that, it's not as clear cut. So size goes up, goes down a little bit, goes back up, goes down. But if we continue on, what we'll find is that towards the end, we're starting to see larger and larger homes. So there is a pattern there. It's not all that easy to pick out. But we can start to see that as the price increases, the size of the house also tends to increase. And we're using the word tends to because it's not a hard and fast rule. Sometimes it goes up, sometimes it goes down, but overall it's tending to increase. So we could also say that larger homes tend to cost more. All right, number 3, finding a relationship between two numerical variables when the data is presented to you in a table is not an easy thing to do. This is very similar to what we saw in Chapter 2. The relationship between two numerical variables can be described in several ways, but as always, the first step is to understand what is happening visually. The primary tool for examining the relationship between two numerical variables is a scatter plot. All right, number 4, the following is a scatter plot for the above data set. So I want to point out a couple of things in here. 1, each of these points represents a house. So 1 point represents 1 house. And this also means that the number of points in our scatter plot tells us the number of observational units or the number of houses in our data set. I also want to point out to you that each point has two values that go with it. Right. If I look at where it is relative to each axis, I'll find that this particular house has a size of around 1,700 square feet. It's hard to be exact given our scale. And its price looks like it's around $375,000. All right, down below, does the scatter plot reveal an association between house size and price? Looks like it does. It looks like it confirms what we saw in the table. It's a little bit easier to pick out though. And as size increases, the price tends to increase. Again, we're using this word in here, tends, because it's not a hard and fast rule. Meaning if we go from left to right, we might find that there's a bigger house that costs a little bit less than another house. Right. So we could also say down here, just like before, that larger houses or larger homes tend to cost more. Right, there's some key features of a scatter plot that I want to take a look at right now. So I'm going to look through that list down below number 5, but I'm going to keep the scatter plot up on the screen. All right, so first thing on your list, the explanatory variable is given on the horizontal axes, and the response variable is given on the vertical axes. So notice here we've got size, and by being on the x-axis, we know that this is our explanatory variable. The x in explanatory can help us remember that. And over here on the vertical axes, we've got price, which then is our response variable. All right, second thing on your list, each point represents one observation or one observational unit. So again, if we count the number of points in here, you should find that there are 22. So 22 points in your scatter plot tell us that there are 22 observational units, or in this case, 22 houses in our data set. And third thing on your list, the location of each point is determined by the intersection of its two values. Right? So we have one example already marked, but let's try a second one. We take this house here, again, where it is relative to the x-axis and where it is relative to the y-axis tells us about the two variables for this particular house. So it tells us that this house is around 1,400 square feet and has a price of around $50,000. If we need more exact values, we'll have to go back to our table. All right, fourth item on your list, the lower left-hand corner of your scatter plot. So that's right down here. Doesn't have to be the origin. It doesn't have to be 0, 0. So this allows you to zoom in on the data and not show a substantial amount of empty space. In fact, if we take a closer look, it looks like this particular point is at 950 on the x-axis and 0 on the y-axis. I'm going to add something to your list here. I want you to take a look at the scale on both axes. And note that they need to be consistent. So you need to use a consistent scale on both axes. But note, the two axes can have different scales, or the scales can be different for the two axes. Okay, so let's go up and take a look at that scatter plot and see. All right, so if we look at the x-axis, we've got 1,000 here and 1,200 there. Take a closer look. If our scale is consistent, that means that this first mark, or tick mark, should be at 1,050. Second one at 1,100. Next one at 1,150. And then that brings us up to 1,200. So our each tick mark is 50 square feet to the right of the previous one. On the vertical axes, we got tick marks here, here, here. So it looks like we're going up by $25,000 each time. And so again, we're using different scales, but they're both consistent. And also notice that they both start in different places. And that's also okay. Okay, number 6, a reminder. When we examine the graph of a single numerical variable, such as a dot plot, stem plot, or histogram, we describe the center, the spread, and the shape. We're going to do something similar with scatter plots. In a scatter plot, we're going to look for the following. So first thing we're going to look for is trend. This is similar to center. It refers to the direction of the association. We're going to find that our two primary choices are either positive or negative. Okay. We're going to look for the strength, which is similar to spread. And this refers to the amount of scatter in the scatter plot. And our choices are typically that there's a weak strength in your association. You might have a moderate strength, or it might be very strong. And at this point, this is going to be somewhat subjective, so we might use a combination of words. And last thing, the shape or form, we're going to be limited to two choices. We're going to have either linear or nonlinear. And we'll take a closer look at these on the next few pages. Okay, number 7, the trend or direction refers to whether greater values of one variable tend to occur with greater values of the other variable. This would be a positive association, or with smaller values of the other variable, which is a negative association. In other words, it's the general tendency of the scatter plot as we move from left to right. Increasing trends are called positive associations, and decreasing trends are called negative associations. Keep in mind that not all associations can be labeled as either positive or negative association. So in our example, it says, which of the following scatter plots shows a positive association and which shows a negative association? And these are on page, or in section 4.1 of your text. And if we look at the one on the left, and we read left to right, what we're going to see is there's an upward trend. So this is a positive trend, or positive association. Here, as we read left to right, there's a negative trend. Right? So said a little bit differently, on the graph on the left, we can see that as the median age of marriage for women increases, so too does the median age of marriage for men. And on the right, the literacy rate, it's on your horizontal axis, as that decreases, the birth rate tends to, oops, I said that backwards. So as the literacy rate increases, the birth rate tends to decrease. If we take a closer look at these, and you get more information from your textbook, but each point in this first graph on the left represents one state. And if you count, there's actually 51 because there's also DC in here. Washington, DC is also included. Okay. So on the left, states where women tend to marry later in life also tend to have men that marry later in life. If we take a closer look at the scatter plot on the right, each of these dots represents a country. So we've got 1 point represents a country. And we can see again, countries with higher literacy rates tend to have lower birth rates. And then as a side, we've got positive and negative. We mentioned that not all associations can be labeled in one of these two ways. So the exception would be if you had a scatter plot that looks something like this, and there's no clear direction, we couldn't use positive or negative. Like we might say there's no trend, no direction in that. Number 8, the strength of the association indicates how closely the observations follow the relationship between the two variables. Weaker associations have more vertical variation and make it more difficult to detect a trend. Stronger associations have less vertical variation, which allows for more accurate predictions. For now, determining the strength of an association is somewhat subjective, and we will limit our choices to weak, moderate, or strong. We'll learn how to quantify this strength later on. So question, which of the following scatter plots shows a stronger association? Again, these are in section 4.1 of your text if you want some more information on them. But if we take a closer look, what we'll find is that this one has a stronger association. This one has a weaker association, might not be weak, might be weak to moderate, but relatively speaking, this one is weaker than the one on the left. And just taking a closer look at this and what they mean by vertical variation. We look at where these points tend to fall in this graph. The vertical variation, it's up and down distance. It's a little bit smaller on the graph on the left. Come over here and try and do that to the graph on the right. We're going to find these are more. This is more vertical variation. So again, a weaker association. Oops, I need to correct that. That should say less vertical variation. And this one has more vertical variation. Just one more example here. If you had a scatter plot that looked like the one I drew up above, so a lot of scatter, this would be even weaker than the one on the right. If you look at its vertical variation, that's got an even greater vertical variation. So this would be the weakest association. Okay, number 9, the shape or form of the association can be either linear or nonlinear. There are a lot of different nonlinear shapes, but we'll just group them all together as nonlinear for now. later classes in statistics or statistics 2 class might go into other models for nonlinear and other options for nonlinear. Linear trends always increase or decrease at the same rate and can be summarized by a straight line. Nonlinear trends are more difficult to summarize and again won't be covered in this class. So which of the following scatter plots shows a linear association and which shows a nonlinear association? And again, these scatter plots are in section 4.1 of your text. So if we look at the one on the left, this one is nonlinear. What we can see if we take a closer look at it is that from here to here, this is a decreasing trend. Then from here to here, again, continuing left to right, we then see that it changes to increasing. And linear wouldn't have that change. On the right is a linear trend. This is the linear one. As we go left to right, what we see is that it continues to decrease. So it's decreasing from left to right. And the amount of decrease or the way that it's decreasing doesn't change. Okay, number 10, you may want to press pause and try this one on your own first. It's number 10, use the following scatter plot to describe the association between house price and size. Be sure to include trend, shape, and strength in your written description and be sure to speak within the context of the data. Now, one note I want to make before I answer this question is that these graphs are typically given a name, and we usually have the Y variable listed first, and we say that it's price versus size, or Y versus X. All right, so back to the original question. We're looking at this association. We want to say something, again, within the context of this problem, or within our data set. So we may say that the association between house size and price is positive, so it gives the direction. Linear gives the form. And we can say the strength of the association is moderate. Maybe moderate to strong. So again, that is somewhat subjective right now. In other words, we can follow this up with as house size increases, the price also tends to increase. Okay, number 11, observations that don't fit the general pattern established by the other points in the scatter plot may be outliers. Following scatter plot displays the weights and heights of students in the statistics class. Which point appears to be an outlier? Offer a possible explanation for why this point is so unusual. And again, this can be found in your textbooks on page 148. And you may want to press pause, give yourself a chance to look at this first before pressing play again. If we take a look at the scatter plot, we're going to find that this point seems a little unusual. If we look more closely at the context, this was supposed to be the student's height, and it was in inches. So a height of about 15, maybe 16 inches seems a little bit unreasonable and probably not very likely or not likely for a college student. So if we offer a possible explanation, it may be that the student had to convert their height. Maybe they're used to it in meters and their conversion was incorrect. Or it could be a clerical error. It was just typed in incorrectly. But the idea, again, is that it doesn't really fit the pattern established by the other points. So if we look more closely at the other points, it seems to be an upward trend here. And this point, again, seems to be unusual in comparison. Doesn't fit that trend.